Section 1.8 discusses scientific notation and significant figures. Let's talk about significant figures first. Significant figures are the meaningful digits in a measured or calculated quantity. It basically tells you how precise your measurement really is. For the example I've given here, 2.531 grams, we can say that the 2, the 5, and the 3 we know with pretty good certainty. But that last digit, the 1, is understood to be uncertain. Let's review that concept with this example. Give the length of the pencil with proper significant figures according to which ruler you use for the measurement. If we're using the top ruler, you can see that we know for certain the pencil is at least 4 units long, but we would have to guesstimate that last digit. So we would say it was somewhere around 4.6. Now if we use the bottom ruler, we know for certain 2 numbers. We don't know the last third one, but we could say for certain that it is 4.12345, and we would have to guesstimate that last digit. So the certain digits in the bottom ruler would be 4.5, and the uncertain digit would be that last one. So I would say it would be 4.55. So again, the purpose of significant figures is to tell you how precise your measurement is. Now, if I told you that something weighed 100 grams and I showed you these 3 numbers that you see on the right, would you think that they are exactly the same numbers? Well, yes, they are exactly the same numbers. They're all 100. But are they all the same as far as significant digits? Are they all the same as far as the measurement that you're taking? The first one, the 100 with no decimal, basically has the last significant figure in the hundreds place. So its accuracy is closer to 100 grams. So the actual measurement, the value of what we're measuring, is closer to 100 grams than it is to 200 or 0, because of that last significant digit in the hundreds place. Look at the one right below it, the 100 with the decimal. Now this one has 3 significant digits, and the last significant digit is in the ones place. All right, so the accuracy is nearest to 1 gram. So what does that mean? That means that the value of what we are measuring is closer to 100 than it is to 101 or 99. Now, what about the last one? If I was to ask you now, which one do you think has the most accuracy, I hope that you would say the last one, because the last one, the last significant digit, is in the hundredths place, so less than 1. The accuracy is nearest to 0.01 grams. So again, if I was to measure that value, I would say that the value is closer to 100 than it is to 100.01 or 99.99. You can see that these things become quite significant when you are measuring really important amounts. Think about doctors and when they have to administer certain amount of drugs to patients. Do you think it would be important for them to be accurate or to have as much accuracy as possible when they are administering drugs into your body? I would say so. All right, well, now that we have discussed why significant digits are important, let's talk about how to recognize significant digits. So there's 4 simple rules. I'm going to talk about the first 2 on this slide. And rule number 1 is a pretty simple rule. I don't even think it should be a rule because it's sort of logical. It says that any number that isn't 0 is significant. So, of course, any number 1, 2, 3, 4, 5, 6, 7, etc. Okay? So if I was to give you an example such as 543, how many significant digits would that number have? Well, it would have 3. What if I gave you an example like 568.762? How many significant digits would that have? Well, that would have 6, because every number in that value is not 0. All right, rule number 2. Any zero that's between two numbers that aren't zeros is significant. I like to call this the sandwich rule. And I've given you some examples in the slide. The first example, 12,098. You see that there's the 1, the 2, a 0, and a 9 and an 8. Well, for sure, we know that the 1, the 2, the 9, and the 8 are significant because that is what rule number 1 told us. But what about that 0 in between those numbers? Well, it's significant because of the sandwich rule. So any 0 between two numbers that aren't zeros is significant. The same goes for the second example, 101. That has how many significant digits? I hope you said 3. And the last one, 987,045. Well, I hope you guys answered that last one correctly. If you don't know what the answer is, we can talk about it in class. The third rule is the zeros before rule. And it says that all zeros before the first non-zero digit are insignificant, no matter what. So for example, 0.000054 has how many significant digits? Well, it's got 1, 2, 3, 4, 5 zeros, but they're all before that first non-zero digit. So that makes it only 2 significant digits. The only thing that's significant in that first number is the 5 and the 4. What about the second example? If you said 3 significant digits, then you are wrong. If you said 4, then you are right. There's 4 significant digits in that second example because that last 0 is part of rule number 2, the sandwich rule, right? It's sandwiched in between two non-zero digits, but the zeros before are insignificant because they are before that first non-zero digit, which happens to be the 8. So rule number 3 was the zeros before rule, but the last rule, rule number 4, is the zeros after rule. So it says that any zeros after non-zero digits are significant only if you see a decimal point. Okay, that is the most important word in that sentence. Only if you see a decimal point. So for example, that first 10,000, do we see a decimal point? No, we do not. So how many significant digits does that number have? I hope you said only 1. It's that 1. All the other zeros are not significant. Those zeros are only there to hold the place for the 1 in the 10,000th place. Okay? The second example, 10,000 decimal, all right, that has how many significant digits? That has 1, 2, 3, 4, 5. Those zeros are significant because we see a decimal point. So the trick here is if you see a number with a bunch of zeros after that last non-zero digit, those zeros will be significant only if you see a decimal point. What about that last example I gave you? 10,000.00. How many significant digits do we have then? I hope everyone answered 7. We have 7 because there is a decimal point between those zeros. Alright, so as a summary, here we see the 4 significant figure rules, and we saw that rule number 1 told us that any number that isn't 0 is significant. Rule number 2 is the sandwich rule, one of my favorite rules. Rule number 3, the zeros before rule, says that any 0 before the first non-zero digit is insignificant. And the last one, rule number 4, is the zeros after rule. And that one says that if you have zeros after non-zero digits, those zeros are only significant if you see a decimal point. I want to point out that for rule number 3, the zeros before rule, even if you see a decimal, but it's before the first non-zero digit, that 0 is still insignificant. Realize that difference between rule number 3 and rule number 4. Alright, so we will practice these in class. So if you have any questions, be prepared to ask them. The next video will be on dimensional analysis and converting units.